Absolutely fantastic. Right, we'll give it a few seconds, a few moments for everyone to join, which provides me exactly the amount of time that I need to introduce this session. So I want to start off by welcoming everyone, and those of you who are still joining. We have a couple of housekeeping items for you today. So if you have questions or you'd like to put your thoughts to the panel, please use the question and answer button at the bottom of your screen in the Zoom window there. And we'll do our best to get through to all the questions, whether it's in and around the topics today, or if it's at the end of the session. We'll do our best to get to answer all of those. And anything we don't answer on the call today, we will include answers to or resources in our follow-ups. A point of note is the webinar is recorded, and we will share this recording along with any resources we mentioned, any links, any databases, anything at all. And we'll send all of that out following the end of the session today. And I think that's everything. Yep, don't forget to use the Q&A. Everything's being recorded, so you're never going to miss out. And I think I will hand over to our esteemed Piers now to do the real introduction and the reason we're all here today.
Thanks, Jason. So a quick introduction to the topic with a little focus on global warming, climate change, and how data in the cloud impacts that. So did you know the last 8 years have been the hottest ever on record? And this month alone included the 7 days that have been the hottest days ever recorded. And this actually crossed paths with the most flights on a single day, so 134,000. I was actually on holiday at the time, so it may have contributed to that number, sadly. Data and the cloud is heating the world, though. It's almost on par with the airline industry. So in 2019, the entire digital landscape was expected to reach 44 zettabytes that following year. And by 2025, over 200 zettabytes of data will be in cloud storage around the globe. So that's a massive demand for cloud services. And it's grown faster and faster every year, much more than our need for air travel has grown, particularly growing over the pandemic as well. And the emissions that are caused by data in the cloud are keeping up with the airline industry and will likely exceed that. So joining us today, we have two Snowflake data superheroes, as well as myself. We have Ruchi and Divyansh, and we also have Francesco, the author of Unified Star Schema and a member of Astrato's R&D team. So without further ado, over to Francesco.
Thank you, Piers. Thank you. Hello, everyone. So today I'm going to share a bit of information about Astrato. Astrato is a product built by Vislib, and it's a tool for data analytics. And I'm presenting it with a particular eye of attention to the topic of global warming. So basically what the topic here is that I will just do a brief live demo, and I will explain what is the difference between the in-memory approach versus the live query approach. And of course, I will discuss the benefits of this, which I can already do a spoiler. The main benefit is that this approach is reducing the data traffic, and it's also reducing the data redundancy on disk. Basically, with Astrato, we store less data on disk and we move less data across the internet. So I'm going to share my screen, and I'll start with this live demo. Okay, I guess, okay, someone should then share. Yes, here we are. Thank you, Piers. I'm sharing my entire screen, and here we are. So I open a browser. So the first thing to say is that Astrato is a cloud native tool. So I'm clicking on bookmark on my browser, and I log in. So the place where I'm in is Astrato production. It's basically the same place that you will see if you register to Astrato. And in this environment, you have workbooks, collections of workbooks, and data. Data is the place where I'm focusing on now. Basically, what you do when you do analytics, you want to have a data connection where you set up all the parameters of your cloud database. And once you make the connection, of course, you don't want to see the entire database, but you want to see a portion. So that's why you build a data view. A data view is a portion of a database where you basically select what you want and you connect it and you do other setup things to turn it into something understandable by business users. And then you are ready to make your analytics. So I don't make a new connection here because it's too boring. So I just simply go to show the list of existing connections. I can go by connections created by me, and I prepared before this a connection to the Snowflake sample database, the one that everyone has. So this Snowflake sample data contains a database that is large enough. I'm not going to use today the largest one, but a large one, pretty large already. So when I select this, what I do, I create a new data view. So Astrato is now browsing the database. And what you see the list of schemas, which are the same that you would see when you go with your browser to visit your database. In this case, Snowflake. You see the same schemas. Okay, so for this demo, I will select, for example, this one. It's TPCH with the scale factor 10. When you click on this, you are selecting everything. I don't need everything. So, for example, I can remove this table. So just to show that we take a part of it. And then once the tables are selected, I want to join them together because tables need to be joined. So now the tables that you're seeing here, you see them because I was fetching the metadata. So Astrato was seamlessly making a query towards the cloud database saying, hey, give me the list of the tables that are available in this connection. And for each table, give me the list of columns. Of course, I say tables, but it's tables or views. So here it is. As a result, we are seeing this as if we were on the database, but we are actually not. We are just seeing this small set of metadata which we imported. So when you want to create joins now, I will not spend much time on this, but basically when you create joins, you need to, for example, you have, I don't know, orders and customer. So you need to drag customer key to customer key, like in all the other BI tools. And then you can rearrange the graphics. And now I'm not going to create all the joins, but fortunately in Astrato, you have the join suggestions. So I can press this button and again, I query the database, not importing the tables, but importing that piece of information that is strictly needed for making the join suggestions. And also, once the suggestions are made, now for example, I see customer pointing to nation, with the field nation key, looks credible. Line item pointing to order with line item order key pointing to the orders order key, looks healthy. But if I want to be sure, I can press show quality. And this is triggering a series of other queries, which I just launched. I launched many of them, 3 for each suggestion. But this way, basically, Astrato is going to extract those select count distinct of a field where it's in the other field. A lot of logics that I don't explain in detail, but basically that are making sure that the joins are correct. They are marked as green because they are correct, meaning that they have some overlap. There are no duplicates of primary keys and so on. I apply this. Until now, I have imported no data. I can also change join, for example. I want to remove this join, and I want to create a join between line item and supplier. So I can do it as I did earlier, or I can drag here, and Astrato is calculating. Again, no import of data until now. Astrato is just giving a list of options, and actually the first one is ranked by probability, and the first one is the one that I want to have. So basically, this is how you build a data view. It's a view on the data, but it's not importing anything but samples of data, and especially it's importing metadata, which is very, very light. Just that you know, this database contains tables that have millions and hundreds of millions of rows. Now I go quickly to create a workbook, and I'll give you a sample on how it works. Again, I want to create a visual. So this is the place where you can choose what dashboard to do. I will just do a plain table. And in this table, I can decide to put some columns. For example, I will put a measure. For example, a customer account balance. It's a number that tells me basically how much money has my customer, I guess. Okay, so now you're seeing a number, and let's make it more interesting. I will add also a dimension, and I will take, for example, again from customers, the market segment. I know that there are not many segments, so it will be a reasonable query. Okay, and I don't like to start with numbers, so I swap the position, and this way I will have the market segments first and the numbers after. Okay, this is an example of a query that Astrato is doing. What is the difference between an in-memory approach versus a live query approach? The thing that I just did in front of your eyes is basically querying the data where it lives, meaning that the database sits on Snowflake. But if I right-click and I look at the query that I produced, you will see that these things that are covering, you will see that here. I can't. I need to move something on the side. Okay. Data query insights. It's the SQL. And this is simply the SQL query that Astrato is producing. So I can copy it. I can even paste it into my Snowflake page and Snowflake worksheet and run it. And I will see the same result. So basically what is happening is that only 5 rows were traveling across the internet. But this millions of rows, because the table here, customer has 1.5 million rows. So these millions of rows are still remaining on the cloud database. You may observe that also other tools have this option. I captured the screenshot earlier on from Power BI. Also in Power BI, you can decide the option between importing the data and doing direct query. So when you import, you literally import all the tables with all the rows, all the details, all the columns. And then when they are in the belly of your BI tool, you can play around. While direct query means that you query the data where it lives. So also Power BI does this. The difference is that Astrato is natively a cloud tool. So it only does the direct query. It only queries the data where it lives. And also the big advantage of Astrato is that the query is a very easy to understand and simple. The same query that I did now, if I do it in Power BI, I did a richer one with 2 fields instead of 1 measures. This one is producing actually multiple queries and it's merging them together, which is still having not much traffic at all, but it is making a bit of confusion. So with Astrato, we wanted to have no data, no copies of large amounts of data on disk, and also have a very simple SQL approach, an SQL that anyone can copy paste. Just that you know, from Power BI, it's very, very difficult to copy paste the SQL. I just did it before this webinar, and it's 2 queries that you can run, and they are partial, so it's a dimension and a measure, and then a second query, which is also partial, a dimension and another measure, and then they are merged together. So in Astrato, it's all very simple. We designed a different way of SQL, where everything is very compact. You just copy paste it, it's 1 query, and it runs on the cloud database. So the advantage really is that a lot of reduction of data traffic compared to the in-memory approach. And everything is also more simple. We believe that we built it because it is the way to do now with cloud databases. But we believe that this is reducing the impact on climate change because we are doing less operations, much less of operations on data. So this is what I wanted to show to you. So I'm sharing the screen and I give the ball back to Piers.
Thanks, Francesco. It was really interesting to hear you talk about how we run efficient queries and can rerun them quite easily, and dive a little bit deeper into the query profiles, etc. In Snowflake, making it nice and easy. And up next, we have Ruchi to talk about her topic. Over to you now.
Thanks, Piers. Hi, everyone. Good morning, good evening. It's an honor to be here. So my topic is about, how does Snowflake supports this climate data change, right? How can we bring it in control using Snowflake? So I think before I get into that, I would just take a step back and, let's understand what is Snowflake and what is the value that it brings on the table. Now, Snowflake, as per their CEO, their mission is to enable every organization to mobilize its data with Snowflake Data Cloud. Now, let's understand how it is done. 4 simple steps. So, the first thing is I call it as ABCD of Snowflake. A stands for you need to avoid data silos. Then B is you build from the ground up. C means that customer is first, and D is data collaboration. So what it means is that you can use Snowflake to build world's greatest data platform to enable governed access to infinite amounts of data. Second, let's talk about Snowflake architecture. Now, using Snowflake architecture, users can integrate data from different types of sources and different types of data, which include structured, semi-structured, unstructured, and that can be used to what we call as enable digital transformation, the actual digital transformation. Third is because of all these services and a lot of others, Snowflake enables a single and seamless experience across multiple clouds. Snowflake is there on GCP, it is there on Azure, it is there on AWS, because of which you can combine the data and you can prevent data silos. And then I think the objective of Snowflake is that with this, users can empower every part of their business with data which is required to create better data products, make faster decisions, and create new revenue streams. So that is at a very high level what Snowflake is doing, how it is changing the world. Now let's understand, because this topic is all about data sustainability, right? So let's understand how Snowflake is supporting that. First thing is, I mentioned about Snowflake architecture. Now, the way Snowflake is, architected, the way its architecture is there, it processes data more efficiently than a legacy system. Now, what it does is, because of which eventually your carbon impact can be decreased, right? Because the performance is faster. Now, what do we mean about the way Snowflake architecture is designed? Now, Snowflake architecture is a hybrid. It's a hybrid architecture, hybrid of traditional, we call it a shared disk and shared nothing database architecture. It's a hybrid of that. Now, it takes the advantages of both. Like shared disk architecture, Snowflake has a central repository in which you store persistent data, and that data can be available from all the nodes. All the nodes can access the data. So the persistent data is stored once in the central repository. Then, like your shared nothing architecture, it works on the concept of MPP. We call it as massive parallel processing, where there are compute clusters, and each node in the cluster, it stores its portion of the entire data set locally. So something that is accessed frequently, that is stored locally. So eventually, user gets a simplicity of shared disk architecture with the performance and scale out benefits of shared nothing. And finally, because of this, the way your queries gets executed, it is faster, and this eventually helps in reducing carbon footprint. So that is one. Second, a very important thing that Snowflake brings to the table is Snowflake Data Marketplace. Now, through Snowflake Data Marketplace, you can discover, you can evaluate and purchase data from multiple different leading data and solution providers. The data marketplace right now has close to 1,800 live data sets, and you can use those data sets. Now, what do you mean by using those data sets? So we as data analysts, we can use that data, we can run some algorithm on top of it, and using that, we can predict, right? We can do those analysis, and we can understand what are the countries that are, let's say, huge, which are having huge carbon emissions. What are the countries where you have a major climate change or bad air quality? So those findings can be generated. And next step is those findings can be pushed back to that marketplace, and from there, your I call them as sustainability advocates across the globe. So they can actually use those findings and they can bring the actual change on the ground. So I think that's the other way that Snowflake eventually is supporting your data sustainability. In fact, there is another thing called Snowflake data clean rooms through which multiple organizations can bring their data together for joint analysis in a secure way, which means that you are reducing data silos. You are not storing copies of data. You're bringing it together and you are executing things one. So I think I can talk hours and hours about this on this topic, but in the end, I would just summarize. I would say that what I've seen is that every step in Snowflake journey is designed in such a way so that your environment footprint is minimum, which means the way their services are, the way their architecture is, in fact the way their offices are structured. They make sure that there are energy saving technology which is being used. I think a lot of us are moving to a virtual world now where let's travel less, let's talk virtually more, because this would eventually result in less carbon footprint. So I think all these baby steps goes a long way, and that's the way I would say Snowflake is supporting data sustainability. So that's it from me, Piers. Back to you.
Thanks, Ruchi. I think my favorite one there is the marketplace. Snowflake have recently renamed it from data marketplace to marketplace because of native apps, which is
Yes.
also, I have to add to that one. It's a great way to share the same code with other organizations and sell it as well. So last of all, but not least, over to Divyansh, and then we'll have a round of Q&A.
Thanks, Piers. Good morning, good evening, everyone. I'll be discussing about more into ESG, the sustainability, and I'll request to move on to the next slide, Piers. Yeah. So what if data could save the planet? So being sustainably focused is hard. To put sustainability goals into action, you need strategy and solutions that are specific to your needs. And we are the architects of the change in building the pathways towards prosperity using data, collaboration, and empathy. To start, we need to assess our business priorities and operational opportunities. And to understand the priorities, we can make use of digital transformation to drive sustainability in various ways by helping enterprises to meet regulations, by enterprises to achieve and enhance differentiated leaderships, by improving the internal optimizations. So think of it as a remapping of your business strategy to a Venn diagram of people, planet, and profit, with impact sitting in the center. So, P.S., if you move on to the next slide, you will I'll show that the Venn diagram. Yeah, that's the one. Now it's a time for an icebreaker question, which we'll be posting in the poll section and even on the next slide. So yeah, while 86% of companies have a sustainability strategy, how many you think have taken action on the strategy? So the poll has been started. You can put your answers on that, and then I'll discuss more. So we got some answers. It's 19%, some has marked 19%, some has marked 35%. So it's actually 35%. What could be the possible reason of this percentage drop from 86 to 35? What do you think? What could be your data points on that? Feel free to mention it in the chat window so that we can have some ideas. One possible reason, which I think could be a reason, is how we are capturing the ESG data. So you can see the stats talking about different technologies, how companies are using to collect the ESG data. You can see from the snapshot that we are still lag at capturing the data with the help of advanced tools and more of strategies are inclined towards primitive methods. So that is where I feel is a drop, which we can say that the the reason of the percentage decrease from 86 to 35. Now let's discuss about IT sustainability beyond the data centers. Enterprises that want to reduce their carbon footprint should expand their sustainability goals to include green IT and responsible computing. Digital technologies are growing source of carbon emissions for companies of all sizes in all sectors. There are typically four interrelated sources of carbon emission within the IT organization. One is definitely the data centers, consumes on an average 250 terawatt hours of electricity in a year, resulting 1% of global demand in electricity and 0.4% of global carbon emission. Second is big data and analytics. It's the driver of the demand of data centers is because of the data-driven analytics of in doing the decision making. So it also plays a contribution towards the high carbon emissions. Security is the third factor. As data infuses with the business processes and decisions, security grows accordingly. Encryption mechanism, blockchain, CPU intensive algorithms requires more computation, leading higher demands of servers and leading to the carbon emission in a global scale. And last not least, it's internet usage. As a global internet traffic grows and due to the digital transformation which we saw during and post pandemic, it led to a higher demand of data infrastructure, leading to a high CO2 emission in the IT industry. So what could be the better approach to drive sustainability in IT? One could be the hybrid cloud. A hybrid cloud opens up the opportunity for sustainable IT strategies. Instead of narrow focus on energy efficiency and emission in individual servers, it allows to focus on improving the sustainability of the entire cloud estate and IT operations. So if I talk about how Snowflake can provide a boost and a benefit on tracking and achieving the sustainability, Ruchi has beautifully mentioned and covered about the Snowflake data collaboration features, which provides a boost towards the green IT initiatives. There are two recent announcements which I wanted to bring in and discuss on the same. Snowpark Container Services, it enables developers to effortlessly deploy, manage, scale containerized workloads using a secure Snowflake managed infrastructure, providing a virtualization to develop the code without making use of an actual hardware resource, reducing the dependencies on the more physical servers. Second thing is the native apps. When the native apps, I mean, native apps is more about creating a data app, but when it mixes and fuses with the data collaboration, like Piers said, it provides a vast opportunity to reshare the code and reshare your application throughout different teams, throughout different accounts and clients, replicating the application code over and over again on the different data centers for the different clients. So these are the two steps which I feel, and I would say these two features towards attaining the sustainability in reusing the code. But then there are other features which are Snowflake offers, like Snowflake is built on the data cloud and it's completely on cloud native, provides various ease of reducing the carbon footprint. Thank you, everyone. This is from me. And over to you, Pia.
So Q&A, if there's any questions in the chat, we'll kick off with those. I had a few questions to get started with, actually. So I'd say back to our first speaker. This one's for you, Francesco. Are there any specific strategies or best practices that organizations can adopt to optimize energy efficiency in their data centers?
All right. Maybe you can unshare the screen so this way we see each other.
Sure.
Together. I don't see. Yeah, that's nice.
There we go.
Thank you. So now it looks more like a panel. Yeah, thank you for that question. So I believe that the topic here is a bit wider. So I think that it's not only about data centers, because then this would mean that there are just a few players, but the topic is really wider, and it involves all companies that are using these services. This is where the challenge should be. Because honestly, when it comes to data centers, I'm quite sure that all the big players are already doing their best to use sustainable sources. Like, Apple has the roof covered with solar panels, and they bring these data centers to the north of the globe. So they already have a lot of these policies. But what can companies do? Companies like us do to improve a strategy that improves the adoption of these services. And I believe that this should be there should be an enforced behavior, as today companies have to pay taxes. They all have to. They should be also forced to make a report on their usage of these resources of data. So they should somehow, there should be, I don't know if I can call it a credit system, but there should be a way to measure how data has been used, quantify it really, and somehow also quantify the computation, because it's not only about the storage, it's also about the moving of the data, and especially the computation, especially when it comes to training of machine learning solutions. So companies should report this. This is what I believe. The only way that we can deal with this challenge is to have it controlled by an institution. And this cascades, so data centers are cascading to companies, and companies are cascading to their clients, or in general to their users. This way, this would make everyone responsible. I'm not necessarily saying that there should be an impact on tax, but definitely if there were also facilitations, incentives, I mean, for companies that have improved their data energy consumption due to data, they should be rewarded by having some tax incentives. I believe it must be taken seriously by the governments, because now it's just impacting for 1%, whatever, but even if we make our effort to improve, but still the volumes are increasing. So even if we improve 20%, but we increase it by 100%, the trend in total is still getting worse. We need to control how much data we use, how much computation we use, quantify our impact on the environment.
Okay, thanks, Francesco. The credit system sounds similar to how carbon credits work. And I know a lot of car manufacturers are trying to buy them from each other, like buying them from Tesla, unused allowance to emit carbon, things like that. I think you're right, if they were pushed down to the customers of these data centers, then each business would have a stronger reason to commit to reducing their carbon. So we have a few more questions, and which one should I pick first? Do you think it's realistic that we can control the impact of data management and reduce our emissions footprint over the next 5 years across the industry?
Probably I can answer that, Piers. So I think, see, the answer is yes. Yes, definitely this can be done. This can be done, but we need to take the right steps. Now, how do you do that? I think a couple of things Divyansh already mentioned, couple of things Francesco already said, but I think we need to talk about reuse and recycle. We have to save energy. Eventually, we need, for example, cutting down on the miles you drive. That's one of the things that we can do to reduce our carbon emissions. We are talking about more virtual meetings here. Fortunately or unfortunately, after COVID world, I think meetings virtually became a common norm, but before that it was not there at all, right? We used to travel here and there for all the meetings. I think the point is that organizations, they should be conscious about their energy consumption. For example, like with green IT and responsible computing, as Divyansh mentioned, again, having an enforced behavior in organizations to quantify the data that they're using, which includes storage and computation, like Francesco mentioned. So overall, it has to be, I think the acceptance is there, but there's still a long way to go. We need to make sure that all these steps are taken care of, and then definitely we can reduce the carbon footprint over the next 5 years. Yeah.
That's interesting. It's definitely a choice within the business to make those changes. And of course, it goes beyond the data center, like day to day, even making sure you've got an efficient laptop, making sure that you're not using too much power, turning off screens, anything like that. So next question, are there any other ESG projects applied to other industries which we could apply to data sustainability?
Who will answer that?
We can come back to that one if you want. Have a think about that one. So some, let's say, more straightforward questions then. There's two questions we have about Astrato. Does Astrato make a copy of the data? And what cloud provider does Astrato use?
Okay.
I'm going to nominate Francesco for that one.
I guess that's mine. Sure. Yeah, I really like that the question whether Astrato makes a copy of the data. So let me answer first the second question: what cloud providers does Astrato use? Of course, the idea is to use them all. So, but we are a company that is growing. So we started with Snowflake and Postgres and BigQuery. So these were our starting points. Then we have Dremio. And now we are working on Amazon Redshift. It's in beta, and more will come, Databricks and other cloud databases. So this is merely a list of things that are in the order how we are managing to implement them. But I like the question about the copy of data. Does it copy data? No, it doesn't copy data. But one thing, it gets temporarily in memory, which is the result of the query. So as you saw earlier, I was querying a data set with millions of rows, but there were 5 marketing segments. So my data set, the result was 5 rows. Yes, those 5 rows are being copied to into Astrato. They go into our backend engine, and the backend sends it to the front end and delivers it to the browser. But this is disappearing, so it's at runtime basically. We are not even at the moment. We are not even making calculations on this. So we may, for example, decide to calculate the totals based on the sum of these 5 rows, but we are not doing that. We are pushing everything to the cloud because we believe it's more correct to do this way. And I don't think that we will do it in the future, simply because many vendors were doing this of copying data, and then they were moving from this approach to the approach of live query. And let me mention Qlik. Of course, Astrato is a company from Vislib, and we are partners of Qlik. So Qlik was historically copying data in memory, and now they are going more and more towards not doing that. So we are already in that direction now.
So we actually call it zero copy BI as well, informally for now at least. So not making a copy of the data. Another question, if you remember actually I'll share it again. This slide, because it's related to one of the questions. Does improving data sustainability reduce cost? And when do businesses see a return on investment?
Okay.
Takers?
So Piers, can you repeat the question again?
So does improving data sustainability reduce cost? And when will businesses see a return on the investment? I imagine it's not immediate.
Yes, I mean, yes, definitely it will reduce the cost. I mean, not eventually we'll start seeing the results at the very early moments, but yeah, it will take time. When I say reduction in the cost, you can imagine that if you are reducing the resources, the consumption of resources, then definitely there will be a decrease in terms of the cost. So that is a main factor, and I believe yes, That's where this Venn diagram comes into the picture. We are not talking about the people and the planet, but also for the profits. And based on that, reaching out the sustainability provides a benefit to the profitability as well to the businesses.
I think
If I can jump in, sorry,
Yeah.
Piers,
Go
I
for it.
wanted to actually comment this. All these policies of sustainability, they all are and they all should be based on the convenience. So of course you can make a regime where you impose things, but the best way to make things happen is to make sure that they are advantageous for the organizations. So if the costs are reducing, then there are chances that companies are doing it because they want to save money. It's convenient for them to do it, and consequently, they are going to the direction that we call the good direction of reducing the waste, let's say, and the consumption of energy.
Yeah, and I recall at Snowflake Summit, it was referenced that Snowflake had worked with, I think it was AWS on their using their new hardware, and they improved efficiency by 15%, and they were able to cut customers' bills by that as well. It reduced the amount of resources being used, also passing savings on to customers. So it's initiatives like that, making sure that we do use the latest technology to be most efficient. So are there any last questions before, or last comments from any of our speakers before we close off the webinar?
I'm seeing that there is a question about the Zoom movement, right? I see.
Would you like to take the question?
I can. I don't know much. I mean, when it comes to Zoom reduce. So the question, I read it, is related to the Zoom movement. Wouldn't more use of Zoom reduce carbon emissions as workers work more remotely? And I think we all agree on that. I mean, we know that in any case now the impact of transport is the biggest so far. So of course, if the trade-off is you use more data, but at least you're traveling less, of course, it's an improvement. But here what we are talking about is, okay, but within data, how can we be more efficient? So we are zooming on the data and saying, provided that this data is needed for whatever reason, what is the way to consume as little energy as possible? So yeah, let's all work remotely. In any case, it's also very good to be able to work remotely. So I am in hot Italy now, hot and sunny Italy, and this is very pleasant. So I guess we all enjoyed a lot working remotely. Clear.
Yes, I know there are a few people that had pandemic workations. So everything that we've discussed is recorded, and all resources will be sent out over email in the coming days. So thank you everybody for participating. Thank you for your time. Thank you for sharing your ideas and thoughts. And thank you for attending to the audience.
Thank you, everyone. Bye.
Everyone, thank you.
Have a great day, everyone.
Thank you, everyone. Bye-bye.